Using the TI-83-84 Plus calculator to determine the linear correlation coefficient and regression equation. The following procedure requires that you have paired sample data in two different lists. We begin by finding the correlation coefficient using the full data set named Nobel Laureate and Chocolate. Chocolate consumption in kilograms per capita is used for the explanatory or X variable, and the data are saved in list CHOC or CHOC. Number of Nobel laureates per 10 million people is used for the response or Y variable, and the data are saved in list Nobel. Press the Stat key and then press the right arrow key twice to select Tests from the top menu. The highlighted item appears as white text in a black box. Use the arrow keys to select the menu item lin-reg t-test and then press Enter. You can also press the alpha key, then COS or cosine key for the letter F to access this function. On the lin-reg t-test screen, the blinking cursor indicates the current input item and highlighted selection. Press Enter after each entry to move to the next input. For XList, enter the list name for the first variable. In this example, we enter CHOC, which includes the chocolate consumption data. For YList, enter the name of the list that contains the second variable. In this example, we enter Nobel, which includes the Nobel laureate data. For frequency, enter the default value 1. For beta and rho, select the option that corresponds to a test of the null hypothesis. To test no correlation, select the option does not equal 0. To test a negative correlation, select the option less than 0. To test a positive correlation, select the option greater than 0. In this example, we are testing the null hypothesis of no correlation between chocolate consumption and Nobel laureates, so we select the option does not equal 0. Press the down arrow key twice, and Calculate will now be highlighted as indicated by the blinking cursor. Press Enter again to view the results. The results include the p-value, correlation coefficient R, and test statistic t. For the regression equation, the results also include the y-intercept labeled A and slope labeled B. There are too many results to fit on one screen, so use the up and down arrow keys to scroll through the results. In this example, the linear correlation coefficient R is calculated to be 0.8006. The results also include the p-value of 0.000. Because this p-value is less than the significance level of 0.05, we conclude that there is sufficient evidence to support the conclusion that there is a linear correlation between a country's chocolate consumption and the number of Nobel laureates. Remember, correlation does not imply causality, and we should use common sense when interpreting results. In this example, it would be foolish to think that eating more chocolate would help win a Nobel Prize. For the regression equation, we refer to the values provided for A and B. These results show that the regression equation can be expressed as follows. The predicted number of Nobel laureates per 10 million people, or Y hat, equals negative 3.367 plus 2.493 times the chocolate consumption in kilograms per capita.